Look around any social media platform or home gardening forum, and you will eventually run into one of the most widely shared pieces of plant advice ever posted. Throw your leftover morning coffee grounds directly into your houseplant soil. Proponents claim that it acts as a magical, free, all-natural fertilizer that turns yellow leaves green, accelerates growth, and saves you money on store-bought plant food. It sounds like the ultimate win-win scenario for environmentally conscious plant lovers. But if you walk into a professional conservatory or talk to an experienced horticulturist, you will hear a drastically different story. They will tell you that pouring coffee grounds into your indoor potted plants is one of the absolute fastest ways to suffocate roots, invite aggressive fungal mold outbreaks, lock up vital soil nutrients, and quietly kill your favorite houseplants from the inside out. So, which side is telling the truth? Is coffee ground application a brilliant sustainable life hack, or is it a hidden death sentence for indoor vegetation? The answer is not a simple yes or no. The truth is that coffee grounds can be an incredible asset for your garden, but when applied incorrectly inside a closed indoor environment, they unleash a chemical and biological chain reaction that actively works against your plant's survival. In this comprehensive guide, we are going to break down the exact chemistry of coffee grounds, reveal the 4 major biological mechanisms that cause them to ruin houseplant soil. Look at what the scientific research actually says about caffeine and soil microbiology, and lay out the safe, proven methods for utilizing coffee grounds without risking the health of your indoor jungle. To understand why coffee grounds behave so unpredictably in potted plants, we first have to look at their chemical composition. When you brew a pot of coffee, hot water extracts most of the soluble compounds, including a large portion of the acid and caffeine. What is left behind in the filter consists of organic matter rich in nitrogen, along with small trace amounts of potassium, phosphorus, calcium, and magnesium. On paper, a material high in nitrogen sounds like the perfect natural fertilizer, especially for foliage-heavy foliage plants that rely on nitrogen to produce chlorophyll and build strong green stems. However, there is a massive difference between raw organic material and bioavailable nutrients. Plants cannot simply eat coffee grounds. Roots do not absorb organic matter directly. For any organic material to yield usable nutrition for a plant, it must first be broken down by soil microbes, earthworms, and fungi through a complex decomposition process. Outdoors in a garden bed, this process happens smoothly because you have millions of square feet of soil, active weather cycles, earthworms, and a vast, diverse ecosystem of beneficial microorganisms. But inside a plastic or ceramic pot sitting on your living room shelf, that natural outdoor ecosystem does not exist. A houseplant pot is a closed, highly limited environment with finite airflow, restricted volume, and a delicate microbial balance. When you drop a layer of wet, nutrient-dense organic waste like spent coffee grounds onto the top of indoor soil, you are introducing a high-concentration waste material into a system that simply lacks the infrastructure to process it. This leads us directly to the first major reason coffee grounds destroy indoor plants: structural soil compaction and oxygen starvation. Coffee grounds consist of extremely fine, microscopic particles. When you dump a handful of wet grounds onto the surface of your potting soil, or mix them directly into the pot, those microscopic particles do not stay loosely separated. As soon as you water the plant, the tiny coffee particles run together and settle into every microgap between the larger soil components like peat moss, perlite, and bark. They form a dense, hydrophobic, clay-like crust right across the surface layer of the pot. Once this dense crust forms, it acts as a literal barrier to gas exchange. Plant roots require oxygen to perform cellular respiration, which is the process that allows them to take up water and transport minerals to the rest of the plant. When the surface of the soil is sealed off by a solid layer of wet, compacted coffee grounds, oxygen cannot enter the root zone, and carbon dioxide produced by the roots cannot escape. the soil transforms into a suffocating anaerobic environment. The roots begin to choke, lose their ability to absorb moisture, and eventually die off, mirroring the exact symptoms of severe overwatering, even if you have not poured a single extra drop of water into the pot. The second major issue is the sudden surge of surface mold and fungal blooms. Spent coffee grounds are moist, warm, and packed with residual sugars and organic carbon. In an indoor setting with still air and room temperatures, a layer of wet coffee grounds creates the ultimate breeding ground for saprophytic fungi. Within 48 to 72 hours of applying coffee grounds to an indoor pot, you will almost always notice a thick, fuzzy carpet of white, green, or gray mold spreading across the top layer of your soil. While saprophytic mold itself does not directly eat living plant tissue, its presence creates two severe secondary problems. First, as the mold spore population explodes, it releases millions of microscopic spores into your indoor air, which can aggravate allergies and pollute your living space. Second, that dense fungal mat further seals the top layer of soil, trapping excessive moisture underneath. When moisture is trapped beneath a layer of mold and compacted organic waste, it creates an ideal environment for root rot pathogens like Pythium and Phytophthora to multiply rapidly and destroy the lower root system. The third hidden danger of coffee grounds is nitrogen immobilization, often referred to as nitrogen lockup. This is perhaps the most ironic consequence of using coffee grounds, because most people apply them specifically to give their plants a nitrogen boost. When you add raw organic matter with a high carbon to nitrogen ratio into a pot, the resident soil bacteria immediately wake up and go to work trying to decompose that new carbon source. To process carbon, these bacteria require vast amounts of nitrogen as fuel. Because the coffee grounds are raw and uncomposted, the soil bacteria will actually suck up all the available free nitrogen currently present in the potting soil to feed their decomposition process. Instead of fertilizing the plant, the coffee grounds trigger a biological feeding frenzy where soil microbes hoard all the nitrogen for themselves. As a result, your plant is suddenly starved of nitrogen. You might notice your plant's lower leaves turning a pale, sickly yellow within a few weeks of adding coffee grounds, leaving you wondering why your natural fertilizer had the exact opposite effect of what you intended. The fourth factor is the residual caffeine content. Many people assume that brewing coffee removes 100% of the caffeine from the grounds, but chemical analysis shows that spent grounds retain a significant portion of their original caffeine. Evolutionarily speaking, coffee plants did not develop caffeine to wake humans up in the morning. They developed caffeine as a mechanism of chemical warfare known as allelopathy. Allelopathy is a biological phenomenon where a plant secretes chemicals to inhibit the germination and growth of competing plant species nearby. Caffeine is a potent natural growth inhibitor. Scientific studies examining the effects of caffeine on root development have shown that even low concentrations of caffeine slow down cellular division at the root tips. When exposed to caffeine, the root elongation process stalls, preventing young root hairs from extending into the surrounding soil. If you apply spent coffee grounds to a young houseplant or a newly repotted specimen, the residual caffeine can actively stunt the plant's root expansion, causing the plant to remain undersized, weak, and highly vulnerable to environmental stress. Now that we have examined why putting raw coffee grounds directly onto indoor houseplants is a recipe for failure, does this mean you should throw your spent grounds in the trash? Absolutely not. Coffee grounds are still a valuable organic resource if you know how to process them safely. The first and most effective way to utilize coffee grounds for your plants is through outdoor hot composting. When you add coffee grounds to a well-aerated outdoor compost pile, they act as a fantastic nitrogen-rich green material. Combined with carbon-rich brown materials like dry leaves, cardboard, or straw, the coffee grounds undergo a full biological transformation. During the composting process, high temperatures break down residual caffeine, eradicate potential fungal pathogens, and allow soil microbes to convert the raw organic nitrogen into stable, bioavailable nitrate that plants can absorb safely. Once the compost has fully matured into dark, rich humus with a sweet forest floor smell, you can safely mix small amounts of it into your indoor potting soil to supply gentle, slow-release organic nutrients without any risk of soil compaction, nitrogen lockup, or toxic caffeine buildup. If you do not have access to an outdoor compost pile or a vermicomposting worm bin, another safe alternative is using liquid coffee ground tea, though it must be prepared with extreme care. To create a very mild liquid fertilizer, take 1 cup of spent coffee grounds and steep them in a gallon of water for 24 hours. Strain the liquid through a fine mesh strainer or paper filter until absolutely no solid particles remain. The resulting liquid will be a very pale, tea-colored solution containing minor trace amounts of soluble minerals. Dilute this solution with equal parts clean water before using it to lightly water your plants once every few months. Because you have filtered out all the solid particles, you eliminate the risk of compacting the soil or creating a moldy barrier on the surface. However, because this liquid still contains trace caffeine and can slightly alter soil acidity over time, it should only be used on acid-loving, heavy-feeding tropical plants like ferns, philodendrons, and monsteras, and should never be used on delicate succulents or cacti. Ultimately, indoor houseplant care relies on mimicking the balance of nature within a controlled, artificial environment. While natural hacks and kitchen scraps sound appealing, potted plants require precision, proper aeration, and balanced nutrition. Standard commercial potting soils mixed with coarse drainage materials like perlite and orchid bark are engineered specifically to maximize root oxygen and drainage, 2 things that raw coffee grounds directly destroy. If your indoor plants are showing signs of slow growth or pale foliage, skip the kitchen waste and opt for a balanced, water-soluble indoor plant fertilizer, diluted to half strength during the active growing season. By reserving raw coffee grounds for your outdoor compost bin and giving your indoor plants the specialized soil architecture they need, you ensure your indoor jungle stays lush, green, and thriving for years to come.